Hey guys, welcome back. Today we're going to talk about simplifying radicals. For Algebra 1, we'll do square roots and cube roots. So a little background, you guys know the symbol that looks like this. We usually call it the square root symbol, but it's actually, the symbol itself is actually known as a radical. Okay, and the X in it, a lot of times we don't see the X, but if you see the X right here, it's actually the index, okay? So the index, when you don't have an index, is actually implied to be 2, okay, meaning the square root. Any other number you could have index of 3, which means the cube root, or you could take the 4th root. We're not going to worry about the 4th root or the 5th root. We're just going to worry about the second root or square root and the cube root. The y is underneath the term that's underneath the radical sign. It's known as the radicand. Okay, and it can be numbers or variables. Okay, so again, if there's no index, we assume it's a square root. Okay, so let's start and talk first about squaring numbers and getting perfect squares. If you square 1, you get 1, 2 would be 4, 3 squared would be 9, 4 squared is 16. Okay, and going down, so if you guys want to just fill these in, you can. All right, or hopefully challenge yourself so you know all your perfect square factors up to 20. Okay, that's what you're going to need for Algebra 2. So we generally multiply as many as, memorize as many as you can. Okay, 225, but we do give you another way to solve it. So this is 256, 289, 18 squared would be 324. And then we have 361 and then 400. Okay, working kind of backwards means if we took the square root of 1, we would get 1. Square root of 4 would get 2. 9, this would be 16. 25, 36. 49, 80, this would be 64. 81, 100, 121, and 144. Okay, so those are all your perfect squares. When you square root a number and it gives you a whole number, then it's called a perfect square. Okay, so right now if you could simplify, for purposes of discussion, we're just worrying right now about square roots that are positive. Okay, the square root of 36 is 6. This would be 10, 7, 5, 8. This would be 2, 9, 12, 4, and 3. Okay. All right, so to simplify a radical, we have two different steps. One is the method of using the perfect square, the largest perfect square, and then taking the leftover. And the second is drawing the factorization tree. Okay, here are your steps. I'm actually going to show you with examples because I find it's a little bit easier. Okay, so I'm going to look at example A. Now A, if I take the square root of 40, I'm not going to get a perfect square. We're not going to get a whole number. So we're going to need to take the number 40, the radicand, and put it into the simplest radical form. So to do that, I'm going to think of my perfect square factors. I'm going to do it two different ways. So in this case, there's nothing there, so my index is 2. Okay, meaning I'm looking for my doubles. So if I wanted to think of my largest perfect square factor, I could think of perfect squares as being 1, 4, 9, 16, 25, 36. My largest perfect square factor of 40 would actually be a 4. So I can represent 40 as radical 4 times radical 10. Okay, and square root of 4 or radical 4 would be 2 radical 10. Okay, so that would be my final answer like that. All right, but the method that we use the most is actually using a factorization tree. It's a little bit easier for when we are looking for cube roots, but if you can identify the largest perfect square factor and pull it out, then you can do it the perfect square method. Now, if I did my prime factorization, and you might remember this from elementary school, if I start with 40, it doesn't matter. I'm going to start with two factors. I'm going to say 2 times 20. Now 2 is prime, so I'm going to circle it. 20, I could say 4 times 5. Well, 5 is prime, and then with 4, I've got 2 times 2. Okay, so I've circled all of my prime factors. Okay, now because my index is 2, I'm actually going to look for all doubles that I have, or all pairs. Now, if I set it up, all my pairs are going to go on the outside of the radicand, okay, because we have 2 times 2, which is 4, and the square root of 4 would be 2. So we kind of pulled that out of the radicand. And what's left over would be 2 times 5, which would be 10. So we would get 2 radical 10. So see how we got the same answer doing it the two different methods. Okay, so 2 different methods, we have the same answer. All right. If we looked at B, if I looked at 27 and I looked at the largest perfect square factor, I'm going to see that 9 is a factor. So I could represent this as radical 9 times radical 3. 9 times 3 is 27. Well, since 9 is a perfect square, I would take the square root of it and I would get an answer of 3 radical 3. Okay, now doing it the other way, if I took radical 27 and I started breaking it down into prime factors, I would get 3 times 9. Let me circle my 3. And then I've got 3 times 3. Okay, so I look back and my index is 2, so I'm looking for my doubles. So on the outside of the radicand, I've got my doubles here. So I'm going to get 1 pair of doubles, which is 3, and then what's left over goes on the inside, which would be 3 radical 3. So notice we get the same answer. Okay. All right, now sometimes we have a number outside the radicand. This number is the coefficient, okay? So again, we call it the coefficient. It's F, coefficient. Okay, so that 3 is a coefficient. Now this is where a lot of kids have problems. They forget about that 3, all right? And I do too sometimes. So I'm going to circle it and bring it down, all right? So going forward, I'm just going to start just doing the prime factorization method, okay? So if I had 32 and I want to do prime factorization, I could say 2 times 16, and then 16 I could do, well, I could stop right there because 16 is a perfect square if I recognize that. But let's do 4 times 4, okay? And then 2 times 2, and 2 times, so whoops, we've got 2 times, let's do this out a little neater. 4 would be my 2 times 2, circle those, and the other 4 would be 2 times 2. Okay, so if I look at this, on the outside we have our 3, so we're going to say 3 times, and we're going to look for our pairs of 2's. We have 1 pair of 2, then we have another pair of 2. And then we look at what's on the left over, which would go on the inside. There's our 2. So 3 times 2 is going to be 6. 6 times 2 is going to be 12. So my final answer would be 12 radical 2. Okay, so why don't you guys try 1, 2, and 3? You can pause the video and then you can try it yourself. Okay, but I'll go ahead and do them. I've got 2 and 10 and 5 and 2. I'm going to circle my primes. Okay, my pairs, I've got a pair of 2s, so I'm going to pull that on the outside. Then on the inside, I have just a 5. So we've got 2 radical 5 as our answer. Okay, square root of 8, we could say 2 times 4. Okay, 4 is 2 times 2. So again, we're looking for our pairs. I've got a pair of 2s here. 1, 2 gets pulled out, and then I've got 2 left over. Okay, and then on 90, let's do 2 and 45. And it doesn't matter what factors you start with. You could have started with 9 and 10. You'd end up with the same prime factors at the end. 9 times 5, and then I've got 3 times 3. All right, so looking at my pairs, I've got a pair of 3s. I'm going to pull those outside the radicand, and then what's left over is 2 times 5. So I'm going to end up with 3 radical 10. You just multiply the 2 at the end. Okay, if I looked at the number 300, actually that one might be easier to do with my largest perfect square factor, so I'll throw that in and go, oh, well, my largest perfect square factor is actually 100. Okay, I could say 100 times 3, and that would just be 10 radical 3. All right, or if you did it the other way, you started with 300 and maybe you did, 30 times 10, and then you said 6 and 5 for your 30, and then you had 3 and 2. And 10, maybe you had 5 and 2. Okay, so I've got all my prime factors. If I look for my pairs, I've got a pair of 5s gets pulled out, and that's going to be times a pair of 2s get pulled out. What's left over is just the 3. That goes inside the radicand, and again, I'm left with 10 radical 3. Okay, so 48, let's do the prime factorization on this one. 6 and 8. We've got 3 and 2, 4 and 2. 2 and 2. I know I'm going kind of fast, but you'll get faster at it. Okay, so there's my prime factors. And if you're somebody that writes really big or messy, I highly recommend using lined paper. Okay, my index here is 2, so I'm looking for my pairs. So I've got 1 pair of 2s gets pulled out. There's another pair of 2s that gets pulled out. And what's left over is the 3, so I end up with 4 radical 3. Okay, if I had done it the other way, my largest perfect square factor would actually be 16. 16 times 3 is 48. So we would again end up with 4 radical 3. So the prime factorization is really just a method of finding that largest perfect square factor. Notice what's on the outside is the largest perfect square factor. In this case, it would be 4 times 4, which would be 16. Okay, now 6 is a little bit different because now my index is actually a 3. Okay, so when I do my prime factorization, I'm going to start out and maybe do 2 times 100. And then I'll do 10 times 10, and then 5 times 2 for my 10 on this side, and then my 5 times 2 for 10 on that side. Okay, so now we're a little bit different. So we're going to draw the radical, and I'm going to put the 3 back in because my index is 3. That means instead of looking for doubles, I'm actually looking for my triples. Okay, so my triples here would be, I've got a triple 1, 2, 3, 3 2s. So I'm pulling a 2 on the outside, and then what's left over on the inside would be 5 times 5 because I can't get a triple of the 5s. So for number 6, I would end up with 2 cube root of 25. It would look like that. That would be my final answer. So a couple of things when you have an index of 3, again, so my index was 3, make sure you write it, okay? If you don't put that 3 there, then it's implied to be a 2. You want to make sure that it's a cube root, okay? So let's try a few more of these, okay? I've got 4 and 17, okay, and then a 2 and 2. My index here is a 2, so I'm looking for my doubles. I got a 2 on the outside, 17 on the inside. Okay, here I've got a 2 as a coefficient. I'm not going to forget about it. All right, I've got 76, so let's do 2 times 38. And then let's do 2 times 19, and 19 is also prime. All right, so looking for my doubles, I've got 1 pair of doubles, 2. Then I'm going to multiply by that 2 coefficient, and then the 19 is left over, so I end up with 4 radical 19. All right, so number 9, my index is 3. So let's break it apart. I know it's even, so I could do divide by 2 and get 216. And then I can get 2 and 108. And then I can get 2 and 54. And then I could do, let's see, 9 times 6. 9 would be 3 times 3, and 6 would be 3 times 2. Whew, there's a lot in there. Okay, so my index is 3. So when I draw the radical, I've got my index in there, and I'm looking for my triples. So I've got 1, 2, 3. Okay, there's triple 2s, and then I have triples 3s. Okay, so I multiply the 2 times the 3 on the outside, and then what's left over is just that 2. So this would be 6 cube root of 2. Is your answer. Okay. All right. So you've got a number of practice problems. So I suggest going through 9 through 15 and practicing them, and then checking them with the answer key that's posted on the class website. But at this point, we're going to actually add in some variables. Okay. So it looks a little more complicated, but it actually isn't too bad. All right. So if I looked at the variable, if I looked at the first one, we're going to treat the coefficient the way that we have been treating it. So I'm going to start out and I'm going to do my prime factorization here. I've got 9 times 8. 9 is 3 times 3. And 8 is 4 times 2. And then I've got another 2 times 2. There we go. Okay, so my index here is 3, so I'm looking for my triples on the outside. Okay, so in this case, I've got a triple 2, 1, 2, 3. So the 2 goes on the outside like that. And I'm going to leave a little bit of space because I want to deal with my variables. What's left over is 3 times 3, which would be a 9. Okay, so that's what's there. I don't have 3 of those, and I'm not going to forget my cube root. Okay, now looking at the variable piece, it's really not too bad. So x to the 4th, I'm actually going to write out 4 x's. Okay, so my index is 3, so I'm looking for how many groups of 3 x's can I have. In this case, I only have 1, so just 1 x gets pulled out, and I have 1 left inside. Okay, now for my y's, again, I'm looking for my groups of 3's, and it's y to the 3rd, so we're only going to pull out 1 y. And that would be my answer. Okay, so again, number 2, we have a coefficient. We're not going to forget about that. We're going to pull it down. Okay, 450, we're going to do maybe 45 and 10, 9 and 5, 3 and 3, let me circle my primes. For 10, I've got 5 and 2. Okay, so in this case, my index is 2, so I'm looking for my doubles. So we're going to get a double 3, and then a double 5. And then on the inside, I'm going to leave space for my variables. I have just a 2. Okay, so now my variables, I've got x squared, and then I've got y. Well, my index is 2, so I'm looking for doubles. So the x would get pulled on the outside. Nothing for the inside for the x's, but the y, I can't get any doubles, so it's just going to stay on the inside. I multiply these together. So for number 2, when I do that, I've got 6 times 15, which is going to give me 80. That 80, let me say 16 times 15 times 6. Oh, that's actually going to give me 90. That's what I thought. Okay, so we've got 90 is going to be on the outside, 90x. And then on the inside, we've got our 2y. And that would be our answer. Okay, so number 3, when we do that, we're going to look at the negative 2. We're going to bring it down. Okay, we've got 120, which is going to be 12 times 10. Let's do the prime factorization. Okay, and 10, we've got 5 times 2. Okay, and let's do the cube root. So we're looking for our triples. So we've got 2, 2, and 2. There's one set of triples right there. Okay, and then 3 times 3 is just going to be 9. So that's going to go on the inside. Is that 3 times? No, 3 times 5. So 3 times 5. So the 15 is going to go on the inside. Okay, and then for our x's, if we have 5, okay, we've got groups of 3. We're going to have one group of 3. Okay, and then 2 left over, so x squared is going to go on the inside. So our final answer would be negative 4x, and then that's going to be the cube root of 15x squared. Okay? All right, so let's look at some more. Okay, so if we have 168, we've got, let's do 2 times 84, and then we'll have 2 times 42. And then let me do 6 and 7. 6 would be 3 and 2. Okay. All right, so on the outside, we have our negative 7 coefficient. All right, and then the radical. Now our index is 2, so we're looking for our doubles. So I've got one set of double 2's. All right, what's left over would be 3 times 2 times 7, which would be 42. So 42 would go on the inside. Okay, and then for our variables, we've got x to the 6th. We're looking for how many double groups do we have? There's 1, there's 2, there's 3. So x would be to the 3rd power. And then our y, we've got 3 y's. Okay, so when we do that, we're going to get, we've got, let me see, that's y to the 3rd power. Yep, we're looking for our doubles. So we've got y on the outside, and then we have 1 left over, so y on the inside. So our final answer would be negative 14. X would be cubed y, and it's radical 42y. Okay. All right, I'll do 2 more, and then I'll let you guys try the other ones. Okay. If I look at number 5, this should be number 5. We've got a 4 on the outside, so we're going to bring that coefficient down. Okay, we've got the number 12, which we could do 4 times 3. And then we've got 2 times 2. All right, so our index is 2, so we're going to pull out a pair of 2's, and then a 3 is left on the inside. When we look at our variables, we've got 3 x's, which means one pair of x's is going to be pulled out, 1 is left over, and then just y, we can't pull out anything, so just y would be on the inside. So our final answer would be 8x radical 3xy. Okay, and the last one I'm going to do with you is going to be this is a cube root, so we're going to take 56 and have 7 times 8. Okay, and 8 we can do 4 times 2, which is 2, 2. So there's all our prime factors. Okay, the 5 is going to be on the outside. Okay, we're looking for our triples. So in this case, we've got triple 2's. Here's our triple 2's. Okay, we're left over with a 7. Okay, and then we have x is going to be to the 8th power. So 1, 2, 3, 4, 5, 6, 7, 8. So to take our triples, we take 3, and then we have 3. So we're going to have x squared, and then we have 2 left over, so we'll have x squared on the inside. So you can think of this as x to the 8th. So 8 divided by 3 is 2, so x squared, and then a remainder of 2. So then when we multiply it out, we've got 10x squared radical 7x squared. And don't forget to put the radical over the whole radicand. Okay, so you guys try 7 through 12 on your own and check it with the answer key that is on the class website. Okay, bye-bye. Let me try to end this.